Scheme actually has another thing called let star, like this. A5 B times 2A, sentence AB, that does what you want if you want sequential evaluation. So what let star is, it's also an abbreviation. It's just syntactic sugar. And what it's syntactic sugar for is nested lets. So that's as if I had typed let A be 5. And now the body of that let is going to be let B be times 2A. And the body of that let is sentence AB. Right? So it's a let inside a let, and that's what the let star does. However many variables you have, it's that many nested lets. And the let is itself an abbreviation for a lambda and a procedure call. So this is an abbreviation on top of an abbreviation. If you find yourself using let star over the next 2 months, you're almost certainly doing something wrong. Later on, when we get to chapter 3, we'll find occasions to use let star, but not until then. Yeah?
Can you have multiple bindings within each, run of let star? So let star acts like nested lets. Is there a way to have multiple bindings in one of those big nestings?
Oh, I see. If you want to do nested lets, but one of the nested lets has multiple bindings in it. No, you have to just say that, spell that out, say what you mean. Because, let's say you have a let star with 5 variables in it, and you want, they're A, B, C, D, E, and you want B and C to be bound simultaneously. Scheme doesn't know that. Maybe you wanted B, C, and D to be bound simultaneously, so you have to actually say it. Let star just does them one at a time. It's hard to imagine a good programming style in which that would be problematic, in which doing them one at a time is desirable for some of them but not others. It's hard for me to imagine anyway. Could happen. Okay, other questions? Okay, I don't see any. So, we now have done the thing about the first classness of procedures, except for the part about data aggregates, which has to wait for chapter 2. And we've done let. I think the coolest thing that we did, out of this week, if I'm going to pick, what's the very coolest thing, it is compose. That's still up here? Yes. Right here. This packs such a lot of meaning into hardly any notation. Because we're talking not about combining a couple of numbers or something or concatenating text strings. We're talking about actually composing 2 different functions, and we're treating the functions as things that you can do operations like composition on completely naturally. There's no special notation because it's a function. It just works. So that's the very cool thing from this week. The other sort of useful thing that comes out of this week is higher order functions that do some of the very, very common tasks for manipulating sentences, words and sentences, like compute this function for each word, or keep the words that satisfy such and such a condition, as we did together in lecture, or combine all the words using something or other. So I can say, let's use reduce. So reduce here takes a function of 2 arguments and applies it repeatedly to the words of the argument. So it actually does it right to left, I think. So we take day and sunshine as arguments to word, put those together, and then we take good and that thing and make word of those. So reduce plus 5, 6, 7, 8, things like that. Okay, so that's a useful thing. It'll take any function of 2 arguments and uses it a combiner. So every first okay. So this lets you very, very quickly throw together sort of medium-sized operations on, for now, text, and later on we'll see on data in general. So here's define acronym of name to be reduce word every first keep lambda word not member word a the what's another thing that we leave out of acronyms of for that'll do, you get the idea. Name. Close the keep, close the every, close the reduce, close the define. Acronym. Okay? So that took me 2 seconds to write, like that. Should take you 2 seconds to write. Longer to read the question, but 2 seconds to actually write the code, because you just get used to the effects of reduce and every and keep and how you can put them together and get great results. They keep trying to change. The Association for Computing Machinery has, as long as I remember, been embarrassed about the fact that its name sounds as if computers should be the members of the association instead of computer programmers. And they keep trying to retrofit a name that will have the same acronym and failing to come up with a good one. Yeah. Association for Computing Mavens. Anyway. Okay, so compose, sort of working at the level of functions, really, really cool. These higher order functions that do things for every word in a sentence or every letter in a word, very, very, very useful. So this is instead of, in that language you grew up with, for I equals 1 to length of the array, do such and such, right? Or if it's a C-like language, it's for I equals 0, I plus plus, no, I equals 0, I less than or greater than? Less than. Length of array, semicolon, I plus plus, array sub I equals such and such, or whatever. So here we don't have to have an explicit looping mechanism. We don't have to have that extra index variable I that isn't really part of the problem. We just take the data, say here it is, do something for every word. It's really slick. And we didn't have to build. We gave you a library that has every and keep and reduce in it. But you can write those. You now know how to write those things. Well, yeah, no, you do. You understand recursion. You know how to write those things. What the language gives you is the ability to use procedures as data. And that turns out to be a hugely, hugely powerful tool for controlling kind of the flow of control in a program. So if you don't like the way every works in some way, you can write your own. Okay? Like every end of letter word, letter, letter, quote, ABC. Well, the return value from every is a sentence, even though the argument is a word. And we did it that way because this function that you're using might return a sentence. I could have said, instead of word, letter, letter, I could have said sentence, letter, letter. And then combining them with word wouldn't have worked, so we just always combine with sentence. But you might want a version of every where if the second argument is a word, then the result is a word. Well, you don't like the decision we made? Fine, write your own. And that's something that's not true about the control mechanisms in languages that sort of build specific ones in and you're stuck with them. So there you are. That's a cool thing about programming. And you can write your own ad hoc higher order functions. I wrote in the Simply Scheme book a tic-tac-toe program. And sometimes it does certain processing on the representation of a tic-tac-toe board. So I can write a higher order function that says, for every square in the tic-tac-toe board, do this. You know, and that would be it's only good for tic-tac-toe programs. But I can write it. It's not hard to write it, so it makes sense to write it as part of a program.